So, before anything else, the two voices explaining AI to you, well, they are themselves AI.
Yeah, which is, either poetic or ironic. We have not decided.
Right. The research and the writing are dance. The voices are us.
Exactly. Machine voices, human mind.
To train a top-tier AI today, you need tens of thousands of GPUs, and, well, each one costs as much as a luxury car. Right now, almost all of that hardware sits locked inside the heavily guarded data centers of three massive tech companies. It is a massive bottleneck. So think about this setup. Could you rent GPU time from anyone with a spare one, exactly the way you rent a stranger's spare room instead of booking a hotel?
This is plain Strata, where we take decentralized AI apart one layer at a time. This is basic 6 of 8, and today it is about renting GPU compute from strangers.
Right, so in our deep dive into the source material today, we are pulling from a massive stack of architecture specs, white papers on decentralized networks, and some highly technical research on hardware security. We're going to figure out how these decentralized GPU markets actually operate. I mean, we need to see where they fit beside those massive cloud providers.
And most importantly, we have to explore the absolute core of this system. We're going to look at a mechanism called hardware attestation.
Right, which is the only way a market of complete strangers becomes trustworthy.
Yeah, and to build that picture, we have to start with the physical reality of a rental. Like if you are renting a spare room, a car, or a massive supercomputer, every single transaction has the exact same 3 parties.
You have a buyer, a seller, and a middleman.
Exactly. You have a buyer who needs the resource, a seller who owns the physical asset, and sitting right between them, you have a middle layer.
That middle layer is the matchmaker, right? Like they connect the two sides.
Yeah, they handle the matching, they process the payment, and they step in to resolve any disputes. The entire philosophical and technical difference between the centralized world and the decentralized world lives right there in that middle layer.
Okay, let me see if I have this right. In the centralized world, we are talking about the household name hyperscalers, or the big GPU-focused clouds like CoreWeave.
Right.
In that environment, the middle layer is just a massive corporation. They own all the physical servers, they set the exact prices, and they guarantee the service.
Yeah, that is the traditional model. It is highly reliable, but they control the pricing entirely.
Because you trust them. They are huge, they are heavily regulated, and you have a legally binding contract.
Exactly. But in the decentralized world, that middle layer isn't a company at all. It is just a protocol.
Just a protocol.
Yeah, it is a set of open source rules running across thousands of independent machines.
Wait, so nobody is actually running the company?
There is no central company running the network. Anyone with a spare GPU can become a seller, and anyone who needs to run a model can be a buyer.
Oh, wow.
The protocol itself takes over the matchmaking, the payment escrow, and the arbitration.
So it completely replaces the landlord with code.
It does. If you look at the root of the word marketplace, it comes from the Latin word mercatus.
Mercatus.
Yeah, that means trade, or literally a physical place where buyers and sellers meet. The decentralized version takes that physical place and the trusted operator who runs it and replaces all of it with pure cryptography and code.
I love that we are dragging ancient Latin into cloud computing. But seriously, how does this actually take shape? Like, if I am a buyer or a seller, how do I practically interact with this code?
It looks a lot like a ride-hailing app, honestly. If you are a provider, you install the protocol software on your machine and you list your hardware on the network.
You broadcast exactly what you have.
Right. You list the specific model of your GPU, how much memory it holds, where your machine is physically located in the world, and, the price you want to charge.
And then the buyer comes in and does the reverse.
Right. The buyer posts a job describing exactly the compute power they need. The protocol looks at the available supply, looks at the demand, and matches them together.
And it handles the money, too.
Yeah, it locks the payment in a digital escrow, and it stands ready to resolve disputes if the hardware fails to perform.
When I look at the landscape in our sources right now, I see 3 major networks doing this. There's Akash, there's IO.net, and there is Render.
Yes, those are the big 3.
Wait, are these all doing the exact same thing, or are they different tools entirely?
Think of them as 3 different doors leading into the exact same room. They all built this identical marketplace shape, but they came from very different architectural backgrounds.
Okay, so let's start with Akash.
Akash is the most established general compute marketplace. It originally started as a way to run standard cloud workloads, like web hosting, on a network coordinated by a blockchain.
So they weren't even focused on AI at first.
No, they were just building decentralized AWS, basically. But over time, they expanded into renting GPUs because, well, that is where the massive demand was.
Right, AI just ate everything.
Exactly. And what makes Akash fascinating is how they handle pricing. They use a reverse auction model.
A reverse auction, so the buyer names their price and the sellers fight over it.
Exactly. The buyer says they need a specific GPU, and they are willing to pay up to a certain amount. Then, all the independent providers with spare capacity bid on that job, driving the price down.
It creates an incredibly competitive environment for cheap compute.
Yes, it really does.
Okay, so Akash started general and moved into GPUs using a reverse auction. What about IO.net? How do they differ?
They are the newer AI-specific entrant, and they are built for massive scale. They focus purely on aggregating GPUs from a huge variety of sources.
Like what kind of sources?
They pull in independent data centers that have spare capacity. They pull in crypto miners who have idle hardware sitting around, and they pull in individual owners. But their major technical difference is clustering.
Clustering, meaning they are not just renting out one single graphics card at a time.
Right. Training a large AI model requires hundreds or thousands of GPUs working together simultaneously.
Yeah, you cannot just do that on one card.
No, you can't. So IO.net built the networking software to take a GPU in Texas, a GPU in Germany, and a GPU in Japan, and stitch them together so they look like one giant supercomputer to the person renting them.
That sounds like a networking nightmare.
Yeah.
I mean, the latency between Texas and Japan must be huge compared to two servers sitting right next to each other in an Amazon warehouse.
It is a massive technical hurdle. That is why they focus heavily on geographic routing and building custom network layers to minimize that lag.
Okay, wow.
Now, the third big player is Render. You might know that name from a totally different industry.
Yeah, Render is huge in the 3D graphics world.
Exactly. Render began its life renting out compute for visual effects artists who needed to render complex, high-resolution scenes.
Right. If you are an artist making a 3D movie, rendering every frame takes an enormous amount of math.
Yes. So Render allowed people with high-end Apple Mac GPUs or crypto mining rigs to rent that power out to artists.
But graphics rendering is very different from AI, right? I mean, graphics are predictable. You know exactly what the frame should look like. AI is more of a black box.
Yes, it is mathematically very different. But recently, Render realized they had an enormous global supply of high-end GPUs sitting on their network.
Oh, so they just pivoted.
Well, they expanded into AI inference. They brought along a totally different artist-led community, but under the hood, they are using the exact same underlying marketplace shape as Akash and IO.net.
So Akash, IO.net, and Render have built the plumbing to match buyers and sellers. But flawless plumbing doesn't matter if the economics don't make sense.
Right.
Why would someone choose this over just going to AWS or Google Cloud?
This is where we see a fundamental split in how pricing works. The big cloud providers mostly sell what is called reserved capacity.
Reserve capacity.
Yeah, they set a fixed, predictable price. You often sign a long contract, and you know exactly what your monthly bill will be.
It is stable. No surprises for the accounting department.
Right. But decentralized markets behave like a spot market. A spot price means you get immediate delivery at whatever price the current balance of supply and demand dictates.
So you do not lock in a price ahead of time.
No, you don't. The prices float freely based on the exact second you request the compute.
So if a lot of people have spare GPUs sitting idle, the price drops.
It drops significantly. Sometimes it drops well below what any big provider would ever charge you. Think of it like buying a last-minute night train ticket.
Oh, I see.
Yeah, sometimes you check the board and the ticket is startlingly cheap because the train is completely empty.
But on the flip side, if demand spikes and everyone wants to train a model at once, the prices climb. They can even spike above the big cloud rates.
Exactly. The only constant in a spot market is volatility. You can't count on yesterday's rate.
It entirely depends on what is free right in that specific moment. You know, I think about it like a taxi medallion versus a rideshare driver.
That is a good way to look at it.
Yeah, like the reserved hyperscaler instance is the licensed taxi. It has a fixed meter, a set fare, and you know what the trip will cost before you even open the door.
Right.
The decentralized GPU is the rideshare driver. Their price surges when it rains, and it dips when the streets are empty.
That is the perfect way to visualize it.
So if you are a developer listening to this and building an AI app, this has a massive practical implication. This means decentralized markets are probably terrible for a steady, mission-critical workload.
Yes, absolutely.
Like if you have an application that needs to be online 24 hours a day, 7 days a week, and millions of users rely on it, you don't want a back-end price that surges on you randomly.
For steady, always-on workloads, the big providers win. Predictability is simply more valuable to a big business than a potential discount.
But if you have a massive overflow of data or a batch of discount tasks that can wait until compute is cheap, this is perfect.
Yes. You just wait for the spot price to drop, run your job, and save a ton of money. Or you could use it to get physically closer to your users, finding a spare GPU in a remote city where the big clouds don't even have a physical data center yet.
It is a totally different tool for a totally different job. But relying on these rideshare-style strangers for overflow compute brings us to a massive physical roadblock. We have to talk about trust.
We do.
Because if I go to a major cloud and rent an H100 GPU, which is a top-tier piece of hardware, I believe them. I trust their corporate reputation.
Right.
But if I am on a decentralized protocol and some anonymous person in another country claims they are renting me an H100, how do I know it is real?
If we cannot answer that question, the entire market collapses into mutual suspicion. No one will buy if they think they are being scammed.
Wait, if the protocol is just open source code, couldn't a malicious seller just hack their local client?
How so?
They could run a cheap 10-year-old graphics card and send a fake digital signal saying they have an H100. How do you prevent digital forgery when you are dealing with anonymous strangers?
We have to go down to the absolute base layer of the hardware itself. The answer is a mechanism called hardware attestation.
Let's dip into the ocean floor here. Explain the exact mechanism. How does a microchip prevent digital forgery?
It relies on something called a trusted execution environment, or a secure enclave. Modern high-end GPUs are manufactured with highly specific features built directly into the silicon.
Into the silicon itself.
Yeah, a small piece of the processor is physically walled off from the rest of the machine.
So even the guy who owns the computer, like the person who physically plugged it into the wall, cannot access that part of the chip.
Correct. The owner's operating system cannot see inside it, and external software cannot alter it. When the chip is manufactured at the factory, a unique cryptographic private key is burned directly into that secure enclave.
So it is like a rental car that comes with a tamper-proof cryptographic odometer.
Yes.
The landlord doesn't have to trust the driver's word on how far they drove. The car's internal computer reports the exact mileage directly to the bank, and nobody can hack the dial.
That is exactly what is happening. The protocol sends a challenge to the machine. The secure enclave inside the GPU uses that factory-burned private key to generate a cryptographic signature.
And what does that signature prove?
It proves two things mathematically. It proves the chip is genuinely the exact model it claims to be, and it proves it genuinely executed your specific batch of code without any tampering.
Wow. The chip itself bears witness against its owner.
Yes. The chip generates a cryptographic proof that cannot be faked by external software.
That is wild.
And when you combine that chip-level witnessing with software benchmarks that sanity check the performance speed, you get a closed loop of trust.
So an attested provider isn't just making a claim on a website.
No, they are proving mathematically that they possess the exact hardware they listed and that the hardware genuinely completed your specific arithmetic.
That is absolutely fascinating. So the protocol does not have to trust the human being who owns the machine.
Right.
The protocol only trusts the cryptography generated by the isolated silicon inside the machine.
This is where decentralized compute markets touch the broader world of sealed hardware security. The word compute itself comes from the Latin computare, which means to count together.
To count together, that is a great root.
It is a quietly fitting name. These are chips whose entire job is doing massive amounts of parallel arithmetic, and now they form the basis of a global market that is built entirely on independently counting whether that arithmetic was really done.
If we surface back up to the main idea, without this hardware attestation, this whole Airbnb for GPUs model just falls apart.
Completely.
Attestation is the anchor. Is the only reason you can trust the network, and the only reason you can confidently send your proprietary code to a stranger's basement in a different country.
It guarantees the room you rented is really the room in the photos.
So we have all these pieces on the board now. We have the protocol acting as the middle layer. We have the spot pricing floating up and down based on real-time supply.
Right.
And we have hardware attestation solving the trust problem through secure enclaves. Let's put all of this together and see it move in a single motion. Walk me through a real-world scenario.
Okay, picture a small AI startup. They are building a new language model, and they need a massive burst of GPU power, but they only need it for 1 week to finish training.
They absolutely do not want to sign a one-year, million-dollar contract with a big cloud provider just for a 1-week job.
Right. So they go to a decentralized marketplace like io.net or Akash. They post their specific job requirements. And because global supply happens to be loose this week, the spot price is incredibly cheap.
So a mix of totally random strangers start bidding on this job.
Yes. You might have a massive independent data center in Europe that has an idle rack of servers for the weekend. You might have a former crypto miner in Texas who has a warehouse full of spare graphics cards.
And then the protocol takes over.
The protocol looks at all the bids, matches the AI startup to the best and cheapest provider, and takes the startup's payment. But it does not give the money to the provider yet.
It escrows it.
Exactly. It places the money in a smart contract escrow.
So then the provider receives the startup's code and runs the data through their hardware.
And as it runs, the provider's GPU continuously attests to the network. The secure silicon generates the cryptographic proof saying, yes, I am the exact H100 model I claim to be, and yes, I have successfully processed this specific batch of arithmetic without any tampering.
And then the AI startup gets their finished work back.
Yes, they can look at the attestation log and know with absolute mathematical certainty they got the hardware they paid for.
And once that happens, the protocol sees the cryptographic proof, automatically releases the payment from escrow, and the transaction is done.
And if the provider had tried to cheat, if they had tried to fake the results with a script or route the job to a sheeper card, the cryptographic attestation would fail instantly.
The dispute mechanism built into the open source protocol would catch it.
Right. The provider would not get paid a single cent, and they might even lose a financial deposit as a penalty for lying to the network.
It is incredibly elegant. You have this massive global coordination of highly complex hardware, moving millions of dollars of compute, and the whole system works flawlessly from start to finish without a single corporate landlord in sight.
It all works because the trust is anchored in the math, not in a company's reputation.
It is a profound shift in how we organize physical infrastructure. But there is a major open question we have to address before we finish.
Yeah, we have to talk about the catch.
Right, I have to introduce the catch here. This is the thread that is really worth pulling for anyone watching this industry. Right now, the whole appeal of these decentralized networks is that they route around the big cloud providers. They give us a much-needed alternative.
Right.
But what happens if those same giant cloud providers decide to step into these protocols?
That is the shadow hanging over this entire space.
I mean, imagine a massive hyperscaler has a tight month, and they need extra capacity for their own internal AI projects. What stops them from acting as a buyer on Akash or io.net and just soaking up all the cheap decentralized compute for themselves?
Nothing stops them.
Or what if they have too much capacity and they step in as a seller, dumping their massive overflow onto these open markets to intentionally crush the spot prices and bankrupt the small independent providers?
If they do that, the total volume of work on these protocols might explode. The network traffic numbers would look fantastic on paper, but you have to ask if the actual property of decentralization survives that kind of pressure.
Right, because if the biggest buyers and the biggest sellers are still the exact same 3 or 4 giant companies, the market might still be technically decentralized in its open source plumbing, but economically, it has been completely captured.
Yes.
It just quietly becomes a thin veneer for the same handful of companies that have dominated compute all along.
A market can have perfectly decentralized code, but if it is captured at the edges by massive incumbents with infinite capital, the reality of the market changes entirely.
Wow.
Watching whether these networks can stay genuinely many-sided with thousands of independent buyers and sellers, or whether they collapse into a convenient backend for the giants, is the most important dynamic to watch in this space.
If you take away just one thought today, keep that tamper-proof odometer framing in mind. Opening up a market to absolutely anyone with spare capacity is a powerful idea, but it only works if you can mathematically prove that the spare capacity is real. Secure hardware attestation is the anchor.
It is what turns a dark forest of anonymous strangers into a market you can actually trust. Up to this point in the stack, the AI has only answered us. It computes when we ask it to, and then it stops completely. The next layer changes that entirely. The next layer gives the AI a goal, it gives it a wallet, and allows the software to act on its own. We are moving into software that does business. We are talking about agents.
This is plain Strata, decentralized AI layer by layer.